forward, let's invite our next speaker for the day. May I invite on the dais Mr. Arnab Majumdar, Deputy General Manager, Technical PNSP, Dow Chemical Inc. Private Limited. The topic is going to be Engage PV POE Enable Module Reliability.
Good afternoon. Can you hear me well? Yep. First, I'd like to thank REI Organizing Committee to give us the opportunity to talk over here. It's an esteemed forum for that. All we are aware that we are witnessing tremendous growth of solar industry in India. What is important is the selection of the right material for the growth of that path. Today we are going to talk one of the very important component. It is Dow Engage PV. It is a POE brand for Dow for the better reliability and sustainability part for the future. Before we coming into the discussion point, briefly we'll talk about our company. Dow Chemical Company is a century-old industry. It's a $45 billion company. We have 106 manufacturing sites spread across 31 countries into that. Our ambition is to be one of the most innovative, customer-centric material science company in the world. Dow is in last 125 years, Dow is always in the forefront of innovation and for the sustainable future and for the growth of our industry. We have a 10 innovation center across the 4 continents in the world. Among them, China or India, one of the important of them. India has always been a very important region for Dow as well, for all the across businesses, kind of that. We already have a 1,500 plus employee in India. We keep growing in India as well. Before we coming to our main discussion point of POE, just wanted to give brief details of the other component, other business we have. We have a different businesses, different product, catering to the entire solar industry. We have different kind of sealants and adhesives from our silicon called Dow Seal brand name. These are used for basically for the frame sealing, rail bonding, and junction box spotting kind of that. The main benefit of this product are excellent bond strength, durability, and performance benefit for the integrity of the case. We have different kind of encapsulant. We are going to talk POE today. Apart from that, we have EVA, and we have very innovative coating, silicon-based coating that is very highly durable, high temperature resistance. We also have some of the silicon coating material for the backsheet repairing that gives restore back the insulation resistance if there is some cracks into that. In essence, Dow is one of the solution provider for the entire solar industry. Now we'll talk about the polyolefin elastomer or POE. We all commonly know that Dow is the world's largest POE manufacturer, and is the innovator and pioneer of this material as well for the industry. And we have a manufacturing site at 3 different continents in US, Europe, as well as we have in Asia Pac as well for that. Our main strength is manufacturing excellency, global outreach, wide application for that. One of the important application of the entire POE is the solar, and it is keep growing. Apart from that, we have automotive, footwear, wire and cable compound, where the POE is also used. Now we'll come into our discussion point. What is the POE and how is it different from another important material of EVA? As we all know, encapsulants are used into the solar modules to protect the solar cell from the external abuses and to give the solar cell protected from any electrical stress because of the high electrical performance. Also provide the right transparency to solar sunlight to come in and generate and maximize the power. There has been many polymers has been used in the solar industry as an encapsulant. Among them, EVA is one of the most popular material, and it is used for the last 30 plus years. EVA has a lot of benefits as well into the industry because it is a very good addition with the cells, good addition with the glass, excellent lamination performance, and of course, it was cost effective as well. But EVA comes with inherent some demerits as well, like EVA very easily degrade and becomes yellow and brown. And because of the degradation, and it's basically lower the performance of the modules and life of the modules as well. Apart from that, EVA generates acetic acid by the hydrolysis of the ester group present into the EVA, and that acetic acid corrodes the modules with time. And it is also reduce the PID performance as well for that. To overcome these kind of demerits and to give the best benefit in the industry, polyolefin elastomer came into the market, and the basic structure of the polyolefin elastomer is entirely different than the EVA material is. It is very much saturated copolymer of ethylene and alpha monomers like butene, octene into that. And the carbon-carbon bond in polyolefins is much stronger than carbon-oxygen or the ester group present into the EVA structure. It does not degrade in presence of UV light or thermal stress to generate acetic acid material into that. That's why the POE is more stable, again the weather resistance kind of that. That is one of the pillar of the reliability. Apart from that, if we look into the another very important factor for the module thing is the insulation resistance, how much protected the module is against all the electrical stresses coming into that. One of the factor is the insulation resistance of the materials, of the encapsulant. Here also POE scores much better than the EVA is because of its non-polar structure into that. It is 50 to 100 times better in insulation resistance at room temperature. If we look into the high temperature as well, like 60 degree and 85 degree, where the insulation resistance of EVA comes down drastically lower level, but it is again the POE sustains 1 to 2 order higher the insulation resistance the EVA is into that. Apart from that, another important factor is called the moisture barrier, because we all know moisture is one of the detrimental factor for the life of the modules. Here, for the EVA, again, it is having 10 times higher moisture permeation rate than POE is, because of the structure difference between the POE and the EVA is. So in essence, if we look at all the three pillars of the reliability, then weather resistance, insulation resistance, as well as the moisture barrier, POE scores much better than EVA as a material of choice. We are seeing POE is one of the material of choice for last maybe 1 decade. We can talk into that as an alternative material to EVA, kind of that. Another factor is called the PID, which plays a very important role into that. There is a many criteria which PID is dependent on, but upon that, one of the more important thing is the particular characteristics of the encapsulant which is responsible for the PID. Like for the EVA, acetic acid is generated into that acetic acids react with the alkaline surface of the glass, generates the sodium ion, and produce the leakage current, and finally the PID. There is a PID loss into the systems. Inherently, POE is much stable as it does not generate acetic acid, having higher insulation resistance and better weather resistance. Its PID resistance is always better than the EVA material is. Here, what we demonstrate that in next 2 slides as well. Here we are talking of the monopark bifacial module. The films are made from the industry, different films of EVA and films of POE taken as designated POE-A and POE-B. And we did the PID studies for damped condition for 96 hours. So we check that. Of course, you can show that the PID of any PID-A and PID-B is much lower than the same modules of the EVA material is. That is one of the factors. And second thing is that one interesting fact, you can look into that, when you combine EVA in the top layer and POE at the bottom layer for the monopark cell, the PID performance of the bottom layer of POEs also comes down. The reason is that, very schematically shown here, is that there is some degraded material, moisture, acetic acid, maybe some other degraded products, diffuses from the EVA layer to the POE layer. It finally impairs and deteriorates the performance, PID performance of the POE. That's why in the combination is always inferior than the pure POEP combination is. Today, apart from monopark bifacial, TOPCon is the mainstream technology in the industry, and TOPCon probably having a position, a market share of 60 to 70% in the global market into that. For the TOPCon cells and the modules, the PID performance is entirely different. It is reverse of the monopark is. Here, the top layer is more PID sensitive into that. That is one thing. And second is that here we use aluminum content silver coating into the TOPCon. And that is highly moisture sensitive. For case of the TOPCon, that's why when you are having the moisture and acetic acid generated into that, it is have a very high impact onto the TOPCon PID performance into that. In next two slides, we are going to show that how moisture ingress into a module's effect. And we have, in the studies, what we've done that, we've done the DA studies for 8 weeks for different kind of modules, taken glass backsheet modules as well, using EVA plus EVA, POE plus POE as the encapsulated film. We studied that. We can show that for case of POE, the moisture absorption rate is much lower compared to the EVA-based studies into that. And same thing has been demonstrated, the right-hand side, EL images as well. We can very clearly, it is visible. The same studies for 8 weeks of DH has been conducted for the power loss part. Here we can also see that the power loss for the POE-based systems is much lower than the EVA-based system is. And one striking point, maybe many of us we know that, for the glass backsheet kind of modules, when EVA is used, the PID is comparatively lower than the glass modules. Yeah, it is apparently surprises us, but thing is that for all the acetic acid generated in the EVA-based system, it does not come out from the glass systems very easily. It accumulates and finally deteriorate the power generation part. That's why glass backsheet shows a better performance for the EVA basis. But in essence, POE is much better of material of choice, POE plus POE for against the EVA-based system, whatever the modules is glass or glass backsheet. Apart from EVA and POE, there is another film is very popular and common today, is called EP. We know that EP is basically a combination of EVA, POE, and EVA. In that, it's made in a 3-layer structure, co-extruded film manufacturing in that. In EP, has basically developed to combine the benefits of EVA and POE, like good addition of cells, of glass, of EVA, better lamination efficiency of that, and PID performance of the POE being in the middle. But there is a two negative important EPE film carries into that. It already contains and carries the negativity of the EVA material has. It is generated as acetic acid. It becomes yellow with time. It has a poor weather resistance. That is one part. And second part is very critical. We have seen, because EPE has come for last 4 or 5 years in the industry. We don't yet to see the long-term performance of the EP into the market. Another important point is the manufacturing efficiency-wise when we make the EPE film, because EVA is basically a polar material, POE is a non-polar material, interlayer addition is not always very good, not uniform. It creates some of the weak spot and finally leads to a failure point into that. That is number one. Second, some of the additives we use into the formulations are all polars. These are very easily moved from POE layer to EVA layer and makes the EVA layer over cross-linking and finally lead to delamination. That's why delamination is one of the important phenomena and problem the module industry is facing for using the EPE film. That is one of the reasons. And third is that in the manufacturing, the distribution of the mass across the film is not very uniform as well. So in a sense, if you just see the spider diagram is that POE still is the better material of choice against the EVA or the EPE system, does not have those things. But what of the deficiencies POE is having, like lower lamination performance or addition? Dow, as an innovative company, we are coming out soon with a very good POE material that will have a very good lamination efficiency, reducing the lamination time as well for that. But same thing cannot be worked with the EVA-based system because we cannot divide off the acetic acid generation or yellowing of the EVA-based system. Yep. At the end, as we summarize that, Dow and Dow's Engage PB POE is one of the material of choice in the industry because it's long-term performance, proven performance in the industry, and it really gives a peace of mind to the entire industry. Yep. And our product has been used in monopark modules, has been using in the TopCon. As you mentioned, it is already have a substantial share into the market into that. And India market is following the same trend, although there is a couple of monofacial modules are made, monopark bifacials are made in India, but we are all moving towards the end TopCon modules in India. For end TopCon and for India market, we think people have started using 100% POE film, or POE in form of the EPE film as well into that. And HGT is another trend in HGT kind of things where also we have some initial data. We are producing that where POE also, where the moisture barrier property is one of the important factors, POE stands and scores much better than the other EPE or EVA film as well for that. And Dow is a solution provider for the entire industry, as we already talked about that. Finally, it gives a peace of mind for all the value chain for the solar industry. With that, I'll stop over here. We'd like to thank for your patience and time spent for that. We have a Dow team that they can be contacted for any product of that. We have a booth in the hall number 12 as well. We'll take a time and visit our booth. We can have a better discussion on the topic as well for that. Thank you so much.
Sir, I have a general question. I'm Dr. Jagdish Shivhare, professor and ex-scientist ISRO. Sir, my question, how sufficiently and efficiently the Dow Chemical Company supports the United Nations Sustainable Development Goals in terms of human, physical, and digital world?
Although I'm not a right person to talk about the big stories of United Nations Sustainability Goal, but we can talk about the sustainability goal part. Dow's have a net sustainability to be net zero is our sustainability goal in future. In addition to that, I need a lot of time to talk on the sustainability, but I don't have enough time. One thing I can talk about that, Dow is one of the largest buyer of renewable energy in the world for our own plant, manufacturing plant, to make it a net zero. We are coming with our new plant in Canada is going to be a net zero plant. And not only that, other plant, we are trying to reduce the carbon footprint as well. Apart from that, we are working with the mechanical recycling, chemical recycling, and many other processes for the sustainable energy. We're coming with a bio-based naphtha, based ethylene as well, polyethylene as well. Overall, we are working into the sustainable goals, sir, to make a better world for all of us. Yeah.
Thank you, sir. Excellent presentation, sir.
Thank you so much.
Excellent.
Yeah.